We're going to talk about derivatives of exponential and logarithmic functions. First, we're going to talk about derivatives of exponential functions. An exponential function is a function that raises a constant to the power of an input and returns the resulting output. So first, I'm just going to show the graph of an exponential function. An exponential function typically looks something like this. One quality of exponential functions that's important that we should note is that they grow very rapidly as x gets very large. Now, I'm going to show you how to differentiate an exponential function. It's pretty simple, it's not too hard. Essentially, all you need to know is that to differentiate an exponential function, you just multiply the function by the natural logarithm of the base. In other words, the derivative of a to the x is equal to a to the x times the natural logarithm of a. That is how we differentiate an exponential function. In this case, a is a constant. Now, there's one special case that we should note in this situation, and that's when a, the constant, is equal to e. In this case, we know that the natural logarithm of e is equal to 1, and we get that the derivative of e to the x is e to the x. It's its own derivative. That's pretty easy to remember, but it's important, so make sure you know that the derivative of e to the x is e to the x. Now we are going to talk about logarithmic functions, and we're going to show how to compute those derivatives. A logarithmic function is a function that returns the power to which a constant must be raised to obtain the input as a result. And so logarithmic functions are inverses of exponential functions and vice versa. Now I'm going to show now the graph of what a logarithmic function could look like. And as you can see, they grow much more slowly than exponential functions. That's an important thing to note. This was just an example of a logarithmic function. Now I'm going to show you how to take the derivative of a logarithmic function. Differentiating logarithmic functions is pretty simple as well. All you must do is you must multiply the inverse of the base's natural logarithm by 1 over x. In other words, the derivative of log base a of x is equal to 1 all over x times the natural logarithm of a. That is how you take the derivative of a logarithmic function. Now, with logarithmic functions, there is also one special exception, and that is when a is equal to e. Now, when a is equal to the number e, we do not write log base e of x, we write ln of x, which is the natural logarithm of x. And we know that the natural logarithm of e is equal to 1, so we obtain the result that the derivative of the natural logarithm of x is simply equal to 1 over x. And this is also a very important result. Now, in general, it's important to know how to differentiate exponential and logarithmic functions simply because they come up a lot. And a lot of the time when you have to take the derivative of them, there'll be another rule of differentiation that you have to use. Maybe the product rule, or the chain rule, or quotient rule. But it's important that you have the derivatives of exponential and logarithmic functions memorized. And so that is how we would find the derivatives of exponential and logarithmic functions.